Thanks. All right. I'm glad you all, glad everybody made it off the boat last night here safely. I like seeing the coffee mugs at 2:30. It helps. Gives me more confidence that you're not going to fall asleep. I'm going to do a quiz and a little game, so I'll let everybody sit down so you get to participate. You have equal opportunity. How many Americans are in the room? Raise your hand if you're American. Sweet. Okay. Everybody can play. Okay. So if you can tell me which one of these states is Kentucky, you have to raise your hand. First one to raise their hand, I'll give you a t-shirt, a Carta t-shirt. No, not 2. No, not 5. You should everybody just start. Just raise your hand. Just take a guess. No, not 4. 3. He's got it. Are you, what size? XL? I think I have an XL. Yeah, here you go. And I have 2 more. Does anybody? Here's a large. Who wants a large? You got it? Medium? Any mediums? There we go. All right, so I'm a data engineer. I'm working for Carta remotely. I work for Kentucky, so that's the reason for the quiz. I work from Kentucky, I should say, a remote worker from Kentucky for Carta. Fun fact, Kentucky Fried Chicken, I'm sure you all know about Kentucky Fried Chicken. My grandma actually met Colonel Sanders a few times. So that's a picture of my grandma with Colonel Sanders in Kentucky. They're not eating chicken, so I don't really know what's going on in the picture, but. So anyway, before I get on to the talk, I just want to tell you a little bit about my employer, about Carta. They sent me here all the way from Kentucky to come and talk about data engineering. Super excited to announce that we just closed our Series E funding round. Andreessen Horowitz is leading that round, and so of course you know the next slide is we're hiring, and I would love to talk to any of you who are interested in working stateside. This is the data team at Carta. So most of the things that I'm going to be talking about in this talk were built by this team. This is a highly distributed team. We've got folks in the Bay Area, San Francisco, Seattle, obviously Kentucky, Brazil. We have a big team in Brazil, North Carolina, New York. So we're kind of spread out all over the place using Slack all the time, like I'm sure all of you are. So the title of the talk is Automating Security in Your Data Pipeline. And the title of this conference, Open Source Data Center Conference. So I was kind of thinking about the ways that we've used open source tools in our data pipeline at Carta, and especially ways that we've instrumented privacy and security inside of our data pipeline. So I probably could have titled the talk Automating Data Pipeline Privacy. Most of what I'm talking about is actually privacy related. It's ideas around how to default to protecting our customers' data in offline systems and analytic systems. So I'm going to briefly talk about regulatory and ethical reasons why this is important to the data team at Carta. And in addition to that, probably the more interesting part to this room is some of the engineering challenges and tactics and ways that we can build tooling that will protect our customers' data. So 3 big ideas in the talk. My goal is for you to take away these key points. Number 1, it's kind of a strange intro, but privacy has an odd and kind of interesting history from what I've read. Number 2 is that privacy-first systems are designed by professionals with ethical behavior and with ethics. And 3, what I consider to be the fun part, that we get to write tools. There's a lot of opportunity from what I've seen for custom tooling, for new open source tools that need to be built around security and privacy. So why should you care? Like why would this talk be interesting to you? What I've observed, and you can tell me if this is wrong, but I think what's happened is the past past decade, probably some of you in this room in the past decade have spent a big chunk of your career taking kind of antiquated systems administration practices and building automated tooling. Basically, I've heard several of you say the phrase, I want to be able to automate my job away, and any mundane tasks or any manual work, I'm going to build automation for that. And the second trend I've seen, and this is what caused me to leave full stack programming and become a data engineer. The second trend I've seen is the hype cycle around machine learning and artificial intelligence. You see it on TV, it's everywhere. And companies were just hiring data scientists, machine learning engineers. The incubators were cranking out new data science programs. And so I think what happened was these data scientists show up at companies and the infrastructure is not in place that they need to do their job. So there is no automation, there is no tooling. They show up at companies and the company's like, okay, we need you to deploy this to this Kubernetes cluster, and the data scientists are like, I don't even know what you're talking about. So I guess what I'm trying to say is that I think there's a huge opportunity if you are interested in machine learning or artificial intelligence for your skill set to, basically I'm pitching you to become a data engineer or to start to get more involved in data engineering in your organizations, because your skill set is extremely valuable and extremely needed in data organizations where probably some of you have seen a mess. And of course, I have to acknowledge the kind of the elephant in the room. The fact that an American is here talking about privacy is kind of absurd. I don't have anything to say. It is what it is. We're doing our best. I'm trying. So earlier this month, Zuckerberg took the stage at the F8 conference, and he sort of, announced that we've done a terrible job of privacy. In the future going forward, we're going to put our customers' privacy first. I'm sure you all have opinions about how genuine that statement is. So anyway, there's massive external pressure from regulators and journalists and the tech community that led to this happening, to him doing this, to this mea culpa on stage at the Facebook conference. But it did get me thinking about the nature of privacy, and especially at working for a company in Silicon Valley, why are we doing this? Like, what is what's the history of privacy? And now that we're starting to develop our own laws that kind of copy the GDPR, like, what does this look like? So let's do a fun little detour into the history of privacy in the Western world, and you can tell me where I'm wrong. So, as you can imagine, religion plays a massive role in the development of privacy in the Western world. One of the earliest places that you see this concept is in Judaism, in the Torah, in the book of Genesis, where you have this story that everybody's heard about. Adam and Eve eat the fruit, they get kicked out of the garden. But I think the part that's not in the story, like the kids' storybooks, is the dark parts, obviously. So the dark part is there's this death that happens in the story where the creator in the story slaughters animals and then uses the furs or the skins to create coverings for these people. So I don't know. It seems like one of the earliest places where maybe the word private parts was invented. Could be. So isolation is another kind of strange development in human history. Humans are tribal species, mammals, species in small communities, and isolation is kind of a dangerous or discouraged behavior in tribal societies. So if you're isolating yourself, separating yourself from the tribe, you could be susceptible to risk. And even to this day in our culture, we We still have kind of these phrases, antisocial behavior, things that we recognize isolation as kind of being like the lone wolf or hermit, or we have a phrase called the odd man out, things that kind of separate people who tend to isolate themselves. Before the in-home fireplace was developed, family dwellings typically didn't even have walls. So you had a family all living together in a small house or a hut, all in one room, and sometimes that would be guests or extended family sharing a single bed together in one big open room. So the idea of having private bedrooms with individuals having their own room, their own bed, is really a modern concept, and beds were actually a luxury item to have. Not everybody has a bed, and would typically be shared by a bunch of people in a home. So you'd have maybe extended family or visitors when they would come to your house would be sharing a bed with you. And you actually see this. The place where you typically see this written down in history is how co-sleeping and sharing beds with guests and visitors contributed to the spread of disease and the plagues. Another place we see isolation. So in the Middle Ages, monks begin this practice of isolation, and it's probably traces back to Jesus being in the wilderness for 40 days, and then in the Sermon on the Mount, he says to go, like when you pray to me, go into your room by yourself and don't let anybody else know what you're doing. So it's kind of this antisocial behavior begins of isolation. So this is a picture of beehive huts on Skellig Michael, and you may have seen these in a recent low budget indie film. Anybody excited for the new Star Wars movie? No Star Wars fans, man. Yeah. So our modern right to privacy definitely has roots in antiquity, however you look at it. Before public and private laws were separated, when that happened in Roman law, there's this idea of the actio iniarium. I have no idea how to say that. A law so the idea of this law was that it starts to protect who a person is rather than just their possessions and what they have. So it's the beginning of this idea of individuals, a concept of individual personal rights. And then if you jump ahead to 1890, there's these two lawyers in Boston, Massachusetts, in the U.S. Who published this article in the Harvard Law Review. And this is a part I had to include when I came across this because one of the lawyers is from my city. And I see his name all over the city, but I had no idea that he was connected with this. So Dorothy Glancy, she argues that this article that they wrote and they published in the Harvard Law Review, it actually created a new chapter in American law. And the title of the article that they wrote, The Right to Privacy in 1890 in the Harvard Law Review. And the authors, their names were Samuel Warren and Louis Brandeis. So they were two law firm partners. Samuel Warren, he was the son, he was the wealthy one. He was the son of a wealthy paper manufacturer. And so the funny part of the story is that it seems like his motivation at least, for writing this paper is his daughter's wedding. The local newspaper had this society section. I think it was called the Saturday Evening Gazette, and they have this society section where they published all the details about his daughter's wedding and what everybody's wearing, the guest list, or the food they had, basically kind of exposing the lavishness of this wedding. And so he was really angry about the fact that the newspaper was publicizing his details, and he felt like it was an intrusion into his family's private life. So that's what led to him exploring this idea. And then the other lawyer, the guy that's from Louisville, Kentucky, Louis Brandeis, He was not wealthy. He's a second-generation immigrant from a Jewish immigrant family from Prague. And it looks like apparently Brandeis actually wrote the bulk of the article. And so his motivations for being involved with this, obviously his buddy, his partner in the law firm, but he was just kind of obsessed with the invention of legal theory. So anyway, in their article, what they argue is that these are the three, big categories that we talk about when we talk about individual rights: the right to life, liberty, and prosperity and property. But what they outline in their article is these two new subsets of legal concepts underneath the right to life. The first one is the right to be let alone, and the second is the right to privacy. So what is the right to privacy? What is that? Brandeis argues that it's the right to decide if that which is theirs shall be given to the public. So that for something about my private life to be made public, it requires my consent. And obviously that's a huge word now, consent. Nobody has the right to publish something that I've created or that I own without my consent. And then, so this is kind of the end of this part, but from there you have technology of the newspaper, telephone, television, all these technologies that expedite the development of privacy law in the Western world. And now until today we have the GDPR and more recently the California equivalent, the CCPA. So I don't know if you can trace back these lawyers in 1890 and the GDPR all the way back to fur coats in the Garden of Eden. Can anybody think of anything older than the Garden of Eden that could be like the invention of privacy? I don't know. I couldn't find anything. It's a strange thought. So my second big idea in this talk is about ethics. Systems that take privacy seriously are designed by ethical professionals. Mark Andreessen, so this is a picture of Mark Andreessen. I didn't just include him just because he was involved in our funding round. I genuinely like this quote. So he likes to say that software is eating the world. And I believe it's true. I mean, we see it everywhere. But if that is true, then a company like Carta that I work for, so we're a fintech company. What we do is we build software that automates the management of your cap tables, allows company to manage employee equity. We also build tools for VC firms and boards of companies. So we're replacing our software is eating away at traditional paper processes, legal processes, legal documents, banking and finance processes. And so we believe that if we're going to replace these with better tools, that we also need to be raising the bar in terms of our ethics and the privacy systems that we build into our software. So one place you see this concept is actually in GDPR, and it's called privacy by design. So I believe, and at Carta, I think we believe that audit defensibility is too low of a bar when it comes to our customers' privacy. So the idea is, what does it mean to treat our customers with the dignity and respect they deserve when we build software? What kind of software can we build as a company that by default protects our customers' privacy, and the default mode favors our customers? Last slide about ethics and legal concepts. Just a quick overview of GDPR and CCPA. So they take the idea of the right to privacy and dignity of customers, and they put it, and these laws put this into law. So before I move on to our tactics and tools that we're using at Carta, Just going to remind you of some of the things that that we put into law. So our customers have the right to know what data we're collecting and storing about them, who it's being sold to, and they have the right to ask us to erase their data, or sometimes you'll see it being called the right to be forgotten. Customers also have the right to assume that when analysts and data scientists are using their data, that they're using personally identifiable information that's been scrubbed or pseudo-anonymized. So regulators are really forcing Silicon Valley to mature, and our responsibilities as data engineers and systems engineers now have more ethical considerations. We see that in our Git commits and GitHub. We see it in design documents, more and more comments, and more interactions with legal teams. So the third section of this talk is the more interesting part, fun part for me. The idea that we can build tools, we can automate away privacy. And that's been one of the most interesting things I've discovered in data engineering is just how many tools still need to be built in this area. So our goal is building analytical systems that automate the protection of our customer data and reduce the potential for human error in data pipelines or for data leaks of sensitive data that could happen in data pipelines. How many of you have seen diagrams like this? Yeah. This one is, the big data landscape. This is one of the most frustrating parts of beginning an analytics project is the tools are overwhelming. So at Carta, we looked at least 30 vendor and open source tools for what we were going to use to build our offline analytics systems, kind of the second generation of our offline systems. And the main takeaway that I had from, and I can see some of the names of the companies that we talked to on this chart, but the main takeaway that I had from the audits and the conversations that we had with vendors and the inspections into open source tools that we did was that some of the biggest companies with the biggest marketing budgets, the most VC backing, when you looked at their SOC report and the architecture of the tool, yeah, when you looked at their SOC reports and maybe I'm too far away. The software architecture. Yeah, it's like as soon as I start talking. Should I swap out? Okay.
Or would you mind taking that?
Yeah, I don't mind. No, it's totally fine. No, it's okay. Test. So, we're doing vendor audits, looking at SOC reports, architecture, getting their, what's it called, signing NDAs, so you can see the software architecture behind the scenes. And the big takeaway for me was that some of the biggest companies had an absolute mess behind the scenes in terms of their security. And then some of the smaller, maybe newer companies had really rock solid architecture. They'd thought through all of the security considerations, privacy first design. And so, yeah, I just encourage you to, when you're when you're talking to vendors and looking at these open source projects, definitely do the diligence to go through and look at how the systems are architected. when we're talking about customer data, really the security posture of your weakest vendor, and that could be the weakest vendor in your data pipeline, is the security posture of your entire organization. So I'm going to camp out on this slide for a minute. What tools did we use in our data pipeline? I kind of want to walk through just our design, our architecture for how we built our analytics systems. It's obviously constantly evolving, and what I'm showing you is just a snapshot of what we have in production, but we are using a mixture of vendor tools and open source tools in our VPC on AWS. We chose Terraform for building infrastructure. I know lots of Terraform users are at the conference. We're big fans of it. We're using Apache Airflow. We have any Apache Airflow users out there? A few, yeah. That does workflow management. We're using Rancher for container orchestration on AWS. Redshift is our data warehouse. We have a data lake in S3. And then on the kind of the end of the pipe, we have Looker for data visualization and business intelligence. And some of our data scientists are also using Jupyter. So it's a busy diagram. Let me take a minute to walk through the different parts of this pipeline. So again, this is offline. This is our offline analytics systems. On the left here, you see basically all of our upstream systems, our transactional databases, and the different cloud services. Just kind of a random sample here of cloud services that run Carta.com in our production application. Apache Airflow. So if you're not familiar with Apache Airflow, it's similar to Spotify's Luigi project, or a newer one is Kubernetes Argo for workflow management. We use it to run Python scripts, Docker containers, Bash scripts, anything that needs to be scheduled or orchestrated. And the blacklist here is just a really simple concept, privacy concept that we've added into our data pipeline. It's really just a Python data dictionary in GitHub. And the basic idea with the blacklist is that this is a blacklist of columns and fields that should never make it from our online transactional systems into our analytical data VPC. We're using Amazon KMS for key management. Airflow DAGs are responsible for encrypting some of the data that comes from our production systems, and so Airflow can get data keys from KMS to do that. And then the JSON schema, you might not be able to see that, but right above S3, we're using JSON schema files and storing those right next to our data in our S3 buckets. So that allows us to manage schema evolution as the upstream objects and tables change. The schema just evolves along with that, and we store that in S3. Oh yeah, not high enough. And then the end users of our data pipeline, all the way to the right, they're using, data scientists are using Jupyter and building machine learning models that can be deployed back into production. Then we have data analysts that are using Looker. Is anyone using Looker? Who's using Looker? Okay. It's similar to Metabase or Tableau. It's used by analysts and data scientists. So yeah, that's a high level of all the tools we're using. Now let me dig into some of the places in this pipeline where we've automated privacy and security. First, I'm going to show you a little bit more about the tool DBT. It was at the very bottom. I didn't mention it. The very bottom of this slide, DBT is an ELT, yeah, extract, load, transform. So the purpose of DBT is to do extract, load, transform, And it's really one of the main tools that's enabled us to switch from kind of doing ETL over to ELT. And this is just a screenshot of the DBT homepage. I wanted to call this out and give it its own slide because I think this tool is really underrated, and it adds a lot of automation to your data pipeline and really improves business processes when you're working with data analysts. Basically, short version of that is it saves you a lot of time. So it stands for Data Build Tool, and it allows you to compose and organize SQL. So analysts can begin to compose and organize their SQL for transforming data in the data warehouse. At Carta, we don't have big data. We're not like a social media company. Our data is very complex. We're a financial services company. And so it's extremely important for us to have a tool like this that allows us to land really complex data in our data lake, in our data warehouse, and then to make sense of it for our team of analysts across the business to be able to make sense of that data and organize it in a way that can be checked in to Git. And that's the big advantage of DBT, is that it allows your analysts to adopt an engineering workflow. So their SQL statements can be checked into Git, do pull requests on them, all the traditional things that we do. It basically combines SQL and Jinja to allow them to do that. It also has a feature for generating data dictionary. So it can generate documentation for your models and diagrams like this one. So this is a data lineage diagram that shows at the far right you have a finance team customer billing details model and all of the models that are upstream that are used to build that, the data lineage for that model. So we use Apache Airflow to run DBT for us. Airflow, like I said, is a workflow manager. It was originally written by Airbnb. Now it's under Apache. And sorry. In Airflow terminology, what we're looking at here is a job, or in Airflow terminology would be a DAG. And every green box in the DAG is an Airflow operator or an Airflow task, so some individual piece of work that Airflow is orchestrating in this DAG. And because DBT is just a command line tool, we can have one of these operators be responsible for running DBT in a Docker container that has all of our DBT code inside of it. I wanted to call out this project too. It's an open source project from Puckle Docker Airflow. So we basically use and copy all of their configuration settings for running Airflow in production. We've just only slightly customized it. So highly recommend this project. And if anybody's considering either moving Airflow into a Dockerized setup on Kubernetes, or starting a new Airflow project, you should definitely check this out before you deploy Airflow into production. And we'd love to talk to you about, configuring it and setting it up, because we spent some time doing that last year. So when Airflow does run DBT, the only thing that you can count on is that distributed systems are going to fail, right? So this is what it looks like when it fails. In Slack, Airflow runs the DBT Docker container, things break, and we need to know about that. So Airflow is also responsible for notifying our team and posting in our Slack channel as soon as DBT fails. And because the data build tool produces detailed run results, we can extract exactly where it failed, what models failed, what was the error message that occurred when it failed. We're also using DBT to detect new potentially sensitive columns that arrive in our data VPC from our upstream data sources. DBT has a data testing framework that's built in. It's really simple, but it's really powerful when you pair it with the metadata tables that you have in any of your data warehouses like Redshift. So I mentioned the blacklist that we have of fields and columns in that Python dictionary. And obviously one of the main problems with having a static dictionary like that in Git is that it gets stale. So our tables and upstream objects are constantly changing. So in this example, the blacklisted fields are Salesforce fields. If you look at account, the billing street field in Salesforce is blacklisted and should not come into our offline systems. But if new fields are added to that account, maybe password or date of birth, then this list is immediately stale. So we can automate checking for sensitive columns just by adding a DBT test. And the basic idea behind a DBT test is that you just write a SQL statement. And if that SQL statement returns 0 records, an empty result set, then the test passes. So the idea is that any record that's returned by this query is an offending record. It's a record that's causing a problem. And so that makes it really easy to debug, because when you need to find out what data is causing a problem, or in this case, what columns might potentially be sensitive columns that have showed up in our data VPC, then we can just run this query and see what new columns have arrived and what new columns we need to go back to the team, back to the business and say, hey, is this sensitive data that we need to encrypt? Should we blacklist it? How do we need to handle this? And to run these tests, it's really simple. It's just a single command, DBT test. And then you can see the results here. So the test suite ran, it completed with 1 error, and the test that we were looking at before, so pretend that it failed, assert no sensitive columns in Redshift. So we're testing to see if there's any sensitive columns in Redshift, and we got back 3 results. So that means that there's 3 new columns that have arrived in Redshift that might be sensitive that we need to look at. So I'm curious how many of you have left a company and months later you still had access to Git repos, SSH credentials. Has that ever happened to anyone? Yeah, it's a problem. It's a really difficult problem to solve. So one thing that we've been working on at Carta is trying to automate access control. So when new members join the team, new services need access to like our data warehouse or our data lake, or people leave the company, any one of those events is going to require things to happen, access levels to be revoked, access levels to change. So our security team has built a system called Gatekeeper, and the goal of this is to give us a common workflow and a common API across the company that we can use to for each team to be responsible for what offboarding looks like when team members are rotated, and what onboarding looks like when someone new joins the team. So this tool is unfortunately it's a work in progress, and it's not open source. Maybe next year when I come, I can show you this. But having a consistent way to automate onboarding and offboarding team members I've seen it be proven to be essential for protecting customer data. So yesterday, Anton gave a really great talk about Terraform best practices. He said it was a little sad because he didn't say anything about Terraform Enterprise, and we're using Terraform Enterprise, and so I was curious about how to use that in the best way possible. But it was an excellent talk, and we're big users of Terraform at Carta. We also use it in a really kind of microscopic way inside of our offline systems to provision access to our data lake to data scientists and new machine learning services that are coming online and going into production to be able to restrict their access to specific buckets inside of our S3 data lake. So this example shows how a module, a Terraform module that creates a new service account user, and then the policy that that user has that grants them access to just one single bucket inside of our S3 data lake. We do something really similar with Redshift. For Redshift access, we're using a different tool. There are some community Terraform modules where you can manage Redshift grants and revokes through Terraform, but we're using a tool called SQL Migrate. So SQL Migrate, another shout out for a great open source tool. It's written in Go. It's a database migrations tool like Alembic or like Django migrations. You've all, or maybe Flyway DB. You've probably all seen at least one of those projects. We've customized it just a little bit to support Jinja template, the Jinja templating language. And you can see where, like in this example, we have a password that's coming from a Jinja template that we can dynamically generate. But the point is that SQL Migrate allows us to completely rebuild our Redshift data warehouse from scratch. The migration in this example creates a Redshift service account and grants access scoped to a single schema in DBT. So we're creating a new known entity service, and that known entity service should only be allowed to use the data that's in this one specific schema in our data warehouse. So probably the takeaway from this slide is that data migrations are not just for web apps. They can be used with great advantage to build data warehouses too. It's kind of like the I know you've all heard the pets versus cattle analogy. What I've seen in talking to other data engineers is that data warehouses are typically treated as pets within companies. Has anyone else seen that? Yeah. So you have this data warehouse, and you maybe have a small team, or maybe even one person that has kind of administrative access, and they carefully groom the data warehouse. So with a tool like SQL Migrate, anything that changes in that data warehouse has to go through code review, GitHub, just all the traditional processes that you do, just like you're building a piece of software. So you can begin to treat a data warehouse as cattle. You can tear it down. You can rebuild it from scratch. Another tricky part of securing a data pipeline is pseudonymity, and this is something that we're still working on at Carta. So today we have these really coarse blacklists about data that's not allowed in our VPC, and we have binary access controls on sensitive columns that we're using Terraform, and access in Redshift that we're using SQL Migrate to control. But if we have the consent of our customers to use, for our analysts to use data to improve products, or for our data scientists to use data to build machine learning models that improve our products, we should be able to separate the full data set from data that is restricted, and separate the restricted data from the non-identifiable data, and grant access to privileged users, data scientists and analysts that can have access to that anonymized data. So I want to talk about some of the techniques that you could use for pseudonymity and pseudonymization in your data pipeline. The first one is to obfuscate the data. So obfuscation is the process of scrambling or mixing up the data. The advantage of this is that it's really easy to do, and there's built-in support for it in most programming languages. This example on the screen is a Python example of how you could do it. And the disadvantage is, like in this example, we're taking the word Mark Zuckerberg and then scrambling it up, and it produces this string at the bottom. So it's just like a puzzle that you saw when you were a kid. And the disadvantage is that it's possible to take that text and unscramble it and get extract the real data from that text. Another technique is masking. Masking is typically used to obscure part of the data, but leave just enough of the data to untouched to be able to perform some basic verifications on it. So everybody's seen this technique used with a credit card where you obscure the first part of the credit card and just leave the last four. And so the advantage of this is that it's really simple for the owner of the data to do some basic verifications on their card number in this example without having to see the full data. But the disadvantage is that some of the data is still stored in clear text. So in this example, you still have some of the customer's real data. You still have that last four of their credit card number in clear text. Tokenization is another technique used for anonymizing data. Tokenizing strings of data is a way to protect data at rest without having to encrypt the data. So it's another really simple technique. Faker is a really popular Python library. Has anyone used that for unit tests or? It's I've seen it typically used in testing frameworks. But it's possible, to use it in this context for replacing real data. So phone numbers, email addresses, you can use Faker to generate fake data to replace that real data. And the advantage of this is that it hides sensitive information from downstream systems, like in our case in Looker, in our business intelligence and data visualization tools. That data is hidden, but it's not going to explode when it hits downstream because the data looks really similar to a real name or real address or real phone number. But the problem with this is there's no way for a privileged user who does have access to, say, like our finance team, if they have access to the billing address, but it's been run through Faker and Faker has generated a fake billing address, there's no way for them to recover the actual real data. Does anybody know what movie this is from? Yeah. I knew there would be somebody that would know. So this is a technique called data blurring, and you've all seen this before. So the idea is that you take some subset of the data and you create like a really coarse approximation of the values. I've actually used data blurring in a couple places to kind of like block out screenshots in this presentation. And another common example where you'll see it is license plate numbers. So he said the movie, it's Dumb and Dumber. So this is a license plate from Dumb and Dumber. The advantage is that you were able to, like, even if you had seen this image without the license plate, you probably could have told me what movie it was from. So you can still see 95% of the image, and just like a tiny little percentage is blurred out. But the disadvantage is I didn't realize this, but you could reverse engineer this. There's a great blog post that's referenced in my slides where, say you're trying to reverse engineer blurred license plates, you can generate all the possible license plate combinations, blur those, and then compare that to your master image. and try to find which ones could potentially match with the image. So there's disadvantages to using this technique. Don't do that with my slides, by the way, on my sensitive URLs where I believe. So encryption is the one that I really want to talk about. The encryption is a technique that we're using at Carta in our data pipeline. One common thing that you hear that came up over and over again when we talked to vendors and looked at their SOC reports was, oh yeah, we use encryption at rest that's provided by Amazon or provided by Azure, provided by Google Cloud, and that is great. I mean, it's great to have that turned on, but it's really insufficient when you're talking about restricted access to restricted data within an organization. So we'd like to be able to encrypt a subset of sensitive data as it moves from those production systems over to the analytic systems. Like in this example, say we want to encrypt birth date as it moves from online to offline systems. And we want the data to remain encrypted through the entire data pipeline and only allow it to be decrypted by a small number of authorized users, people that have access to the encryption keys and people that and also have access to the data. Obviously, the advantage of encryption over some of the other techniques we've talked about is that the original data can be recovered. So if you have access to the data, you have access to the key, you can decrypt that data and get the original value. But it comes with disadvantages and trade-offs. It adds a lot of complexity to your data pipeline, and there's a bunch of trade-offs when it comes to how you're going to implement your encryption scheme, whether you're going to use asymmetric or symmetric encryption, or you're going to use HashiCorp Vault, or you're going to use KMS. There's lots of things to consider. So right now we're using the AWS Key Management Service. It allows you to automate key creation and key rotation and gives you lots of options for how you want to do that and what scheme you want to use. So we can use Terraform to create a customer master key in KMS. And then in our Airflow DAGs, we can use like a tool like Botto3, a library like Botto3 to generate a new data key. So that's what Botto is doing here. We get the Botto client, and then we run generate data key. So in this example, the key is not, the customer master key is not stored in our environment variables. So there's no, you're not having to worry about handling, storing your master key. We strictly just store the KMS Amazon resource number and get the master key using that, and then generate a data key. And the data key is never stored in Airflow. It's never written to disk. It's just used for the encryption. At Carta, we are heavy users of Postgres. Postgres comes with a PGP Crypto module that provides you with a variety of encryption methods. So say we wanted to encrypt that birth date column in the users table, and we want to do that at query time when we're ingesting data from the users table and bringing it into S3 or Redshift. The PGP Crypto extension has a symmetric encryption function. Yeah, you can see it right here. So PGP Sim Encrypt, we can encrypt the birth date column and pass in the encryption key. Obviously, it wouldn't be hard-coded in your code. Get the encryption key out of AWS KMS and encrypt that data. And the advantage here is that we can push that work of encryption up into our standby Postgres database instances. The data will never arrive in our data VPC in clear text. So for these sensitive encrypting columns, the goal is to leave that data encrypted from the time it arrives in the data VPC and that data pipeline and all the way through the pipeline, and then just decrypt it in the last mile, decrypt it at runtime, I guess you could say, like when it's being retrieved. Most of our data access is happening against these systems is happening in Looker, in that BI data visualization tool, and we run that on-prem inside of our VPC. So Looker is connected directly to our Redshift data warehouse, and just like Postgres, we can use some encryption functions and take advantage of encryption inside of Redshift. Redshift doesn't have the PG Crypto module, so it can't just use the same symmetric encryption functions there, but it does have support for user-defined function, Python user-defined functions. So we can just write a function like this one, AES decrypt, that can decrypt that birth date column. So this is just one way that you could encrypt data at the very beginning of your data pipeline and then decrypt it at runtime at the very end. But choosing to do this technique, to encrypt individual columns and encrypt subsets of data, is definitely complicated. So encrypting personally identifiable information like this, like the birth date example, comes with a long list of decisions, because now you've got, your organization has to manage keys. So if you use KMS, you need to decide, am I going to let KMS do the default mode, rotate my master key annually? Is that enough? Or do I need to do manual key rotation? Do we want to rotate our key every day? Is it even acceptable to have a single master key for all this data? So then you have to ask yourself, should we create different master keys for different groups of users? So like the finance team has a master key and marketing has a master key, and only those subsets of data can be decrypted. Or another consideration is, can we install encryption keys in our BI tools behind the scenes? Or are we going to ask our analysts to have to learn about keys? So we're going to push work down into our end users and be like, yeah, we need you to get the key from this system and plug it in here when you're trying to retrieve this certain subset of data? Or is there a way that we as data engineers can build the system and automate that process of updating keys? And then under what circumstances do you need to re-encrypt the data? So when a team member leaves, like we were talking about earlier, and they have access to sensitive data in the company, how are you going to handle that? Are you going to rotate the keys when only certain people leave, when anyone leaves? And is rotating the key enough? Do you need to go back and re-encrypt certain subsets of data, re-encrypt all the data? So column level encryption like this, it comes with a lot of complications, a lot of design decisions that you would need to hash out if you decide to take on this scheme. So just to quickly summarize what I've been talking about, the three big ideas from this talk. Number one, that privacy has a strange history, I think. And fortunately, we're living at the point in history where we have things like GDPR and CCPA, and it's just accepted that that privacy is a human right, that we need to build systems that respect this. The second point is that we are responsible for doing that. We're ethical professionals who customers haven't trusted with their data, and we're responsible for it. And then the last part is that there's lots of tools that need to be built for this. I showed you some examples of tools that we've had to custom build. Certain cases we couldn't find, or the vendor tool was too expensive that would accomplish what we needed to, or the vendor tool did too much. Lots of opportunities for new, small, single-purpose open source tools to be built. And we can do that. We can automate the pain out of taking care of our customer data. So my name is Troy Harvey. I'm a data engineer at Carta, and I just wanted to thank you all for your time and attention.